Okay, here's warm-up number 47. So this segment here is called a mid-segment of a triangle because it connects two midpoints. And the idea is the mid-segment is going to be half the length of the side that it's parallel to, so the side that it doesn't intersect. So 48 should be half of 3x. So what I can do, I can just double the 48. I can say 2 times 48 is going to equal 3x, and then I can solve this for x. So let's see, that's 80 and 60, 96 equals 3x, and that's going to be, when I divide by 3, I'm going to get 32. And I've solved for x. Okay. All right. Next up, let's find the circumcenter. So this is going to be where the perpendicular bisectors meet. Okay. So I'm going to find, you can find all 3 perpendicular bisectors, but you really only need to find 2 of them because all 3 of them are going to meet in the same point. So when you've got a situation like this where you have horizontal and vertical lines, use that to your advantage because it makes it really easy with the bottom of this triangle, say, to find the midpoint. I could use the midpoint formula, but I can see, hey, midpoint's right there, right? It's 4 units across, so I just cut it in half like that. There's my midpoint of the bottom. And then, if I want the perpendicular bisectors, since this is a horizontal line, I just make a vertical line that goes through that point. Okay, there's one perpendicular bisector. Okay, I'll just mark that to show that. So let's find the perpendicular bisector of the left side. So I can see this is 6 units tall. So I'll just cut it in half. Okay, and this time I'll make a horizontal line so that it's perpendicular that goes through that midpoint. Okay, and I've got two of my perpendicular bisectors. I don't need to bother with the third one because I already found this intersection. Okay, when you have a right triangle like this, it just so happens the circumcenter is always going to be on the hypotenuse, and since that's going to be where my perpendicular bisector goes, it's actually always the midpoint of the hypotenuse. So another way you could do this, if you have a right triangle, is find the midpoint of the hypotenuse. That's always going to be your circumcenter. So in this case, this would be the point 2, 3. And that's my answer, okay? And the circumcenter, just while we're at it, is if I drew a circle that went through all 3 corners of this triangle, and I'm not doing a great job here, but hopefully good enough to get the idea. You know, I could use a compass if I wanted to do a better job. But the center of that circle is the circumcenter, right? So it's the center of the circle that you can circumscribe about a triangle, okay? All right, next up, we've got some midpoints. They tell us that these A, R, and T are all midpoints, so let me mark that in my picture here. Okay, and that means that each one of for the smaller triangle on the inside, each one of these sides is going to be a mid-segment because this connects 2 midpoints, right? So that's a mid-segment. So what I can do here, this is going to be half the length of 29, okay? So, and that just, I wasn't really looking at the questions, but that's going to be for part C because I'm going to use that to find AR, okay? So if I call this X, I can say 2 times X equals 29 because the mid-segment is going to be half the length of the side that it's parallel to. So then I divide by 2, and X would equal 14.5. So that's what AR is. Okay, I should really have the little bars on top of those. I think I missed them. Okay, so I'm going to do the same thing with the other 2 sides. So let's look at this one. So this corresponds to that side. So let's call this one y just to get a new variable. RT, okay, this is part B here. So I'm going to say 2 times y is going to equal 19. And then divide by 2, and y is going to be 9.5 then. So RT has a length of 9.5 units then. Okay. And I don't know if I have another color. Oh, yeah, I do. Okay. So this is going to be the mid-segment that corresponds to that side. So I'll call this Z just to get a new variable. So 2 times Z is going to equal 35. Divide by 2, and I'm going to get 17.5, right? And so z equals 17.5, and that's also the measure of segment AT. Okay, that is the end of the warm-up, and I'll see you next time.